Here's the last problem from section 2.1. The topic we ended with was determining if a function is even or odd or neither and doing that analytically. So before we do this problem, just remind me, just to get our brains loose and going, what does it mean if we say that a function is even? What's that referring to? Same y values, yes. So it's symmetric about the y-axis. If you go the same distance in the x direction, you end up with the same y values. And so you get a function that, if it was like a greeting card and you fold it on the y-axis, it's going to be the exact same thing both sides. It's called symmetric with respect to the y-axis, but the fun math word is even. And then what does it mean for a function to be odd? It's not symmetric with the x-axis because if something's, the reason I didn't mention it, and we don't really focus on it in this class, is if something's symmetric with respect to the x-axis, it's not a function. So we are dealing in this class with the algebra of functions, so we don't really, I don't really bring up symmetry with respect to the x-axis. Good thought. Where is a odd function symmetric? It's not symmetric about a line, it's symmetric about the origin, a point. And I told you the visual test, if you're given the function, is put your finger on the origin, spin the graph 180 degrees, and you should get the same thing. So now we are going to do the analytic test. So I don't have the tools right now. This is a pre-calculus thing. You'll learn how to graph this. It's not too big of a deal, but that's not for our consumption. So what we do is we're going to start with this statement right here. And what this says is if I go in the negative direction, what happens to this function? So if I go in the negative direction and I end up with the exact same function, the same y value, that means it's even. If I go in the negative direction and I end up with the opposite, so both of these terms would be the opposite sign, okay, that would be odd. And then if it's some mishmash of those things, then it's a neither. So I'm going to start with this. I'm going to plug in a negative x in here. So I've got negative x squared plus 5 times negative x. So all I've done is everywhere there was an x in the original function, I've plugged in a negative x. And let's see what happens. And it's kind of the same. Now, in this class, we have the 6 basic functions we're dealing with right now. So you kind of fall into a routine doing this. With whether it's an even power or an odd power, that's why they're called even and odd. But learning this analytic test, if any of you are going pre-calculus after this, if you're going to trigonometry, there are functions that are even and odd, but they don't have any powers. Okay, lots of fun to deal with, but so it's important to learn how to do this if that's where you're heading. So when I take a negative number and I square it, a negative times a negative is a positive, so that negative disappears and I just have 3x squared. And then this goes back to just what we learned about multiplying variables and coefficients. A positive 5 times a negative x, a positive times a negative is negative 5x. And my conclusion is this the exact same thing that I started with? Now, the 3x squared is good, but then I changed the sign on the 5x. Is this the exact opposite? Is every term the exact opposite of what I started with? No, these are both positive, and I've got one of each. So this is an example, and I spoiled the surprise for you at the end of class last time. I told you you should expect this result. This is a neither. There's no symmetry with respect to the y-axis. There's no symmetry with respect to the point of the origin. And that was our last example from the previous section.